Okay, this is kind of a catch-all for what we've been working on the last week or so. So what we're trying to accomplish with this page right here is that we want to be able to see the relationship between the area of a square and the side length. Okay, so if we look at if we look at this square here, we know that the area is 1, okay? And if we look at the side length here, the distance is also 1, okay? We look at this one, the area is 4. There are 4 whole blocks that can fit inside this. And if we look at the side length here, there's 1 here, because we're counting the spaces in between the dots. We don't count the dots themselves, we count the spaces between the dots. So we have 1 space here and 1 space here, so the side length is 2. Okay, this one we have 9 blocks inside here. So the area is 9. And if we count the side length here, we have 1, 2, 3, because again, we're not counting the dots, we're counting the spaces in between the dots. So our side length is 3. All right, so if we look at this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the area is 16, which it already is telling us. And again, if we look at the side length, okay, we can see 1, 2, 3, 4. So the side length is 4. All right, so if you look, if you look at the side length, right, we know that the side length over here is, excuse me, also 3. The side length here is also 4. The side length here is also 2, and the side length here is also 1. And so finding the area of a square is just taking side squared, which just means side times side. I don't want that. Oh, good grief. Okay, so it's side times side, okay? So this number here, when we take it times itself, it should give us this number over here. So 1 times 1 is 1. 2 times 2 is 4. That goes with this one here. 3 times 3 is 9. 4 times 4 is 16. Okay? The other way we can think about this is that if we take the square root of the area, it's going to give us the side length. So if we take the square root of 4, we're going to get 2. If we take the square root of 9, we're going to get 3. If we take the square root of 16, we're going to get 4. Okay? So what happens with these here? Because if we take the square root of 2 in our calculators, okay, if we take the square root of 2, we get some decimal. Okay? So what we do in that case is we just take this number and we just put the square root of 2. This would be the square root of 5. This would be the square root of 6. This would be the square root of 10. So the side length here, if the area is 10, then the side length here is the square root of 10. The area here is 5, so the side length is the square root of 5. The area here is 8, so our side length is square root of 8. The area here is 2, so the side length is the square root of 2. Okay? And we can similarly write that up here, because if we take the square root, if we take the square root of 4, my pen will write, we know that the square root of 4 is 2. We know that the square root of 16 is 4. We know that the square root of 9 is 3. So we can write this, the square root of 9 is equal to 3. The square root of 16 is equal to 4. The square root of 4 is equal to 2. Okay, so again, here, what we're just looking for is, we're looking for the relationship between the area and the side length. So you can kind of think of it like this. The side length is equal to the square root of the area. Now, if it comes out evenly, if it's a perfect square, like if we do this, okay, and you punch it into your calculator, well, the square root of 36 is 6, so we can write the side length here as just 6, okay? If we type in over here, square root of 3, this comes out as some weird decimal, so we just leave this one as the square root of 3, okay? This one, square root of 121, if you punch that into your calculator, you would get 11. Over here, if you punch in the square root of 28 into your calculator, you're going to get a decimal, so you just leave it as the square root of 28. The square root of 1 is just 1, so you can write 1 for your side length. Here, we're taking the square root of 100, which is 10. And over here, the square root of 11 is a decimal, so we're just going to leave it as the square root of 11. Now, the other way, if this, so again, if we think about the side length is equal to the square root of the area, so the number that's underneath the radical sign tells you what your area is. All you have to do is just square this. So if we were to do this, the square root of 5 squared, this is going to cancel with this, and so what you'll be left with is the area. So the area is equal to 5. If you take the square root of 1 and you square it, you get, this cancels with this, so you're just left with the number, which your area would be 1. Same thing here. If you take the square root of 6 and you square it, the square root sign cancels out with the exponent, and you're just left with 6. Okay? So see if you can figure out what the areas of each one of these other ones would be here. I'll give you a few seconds. Okay, so your area for this one should be 8. Your area for this one should be 13. And your area for this one should be 10. Okay, so we're going to kind of talk about the concept of what a square root is, and think about a square root as the side length of a square with a known area. So this is where it gets a little bit tricky. I'm not going to play the song for you. Okay, so the area of a square is the length of the side multiplied by itself. So if you think about the side length, if we look at this square right here, we know that the side length here is 2, and we know that the side length here is 2. And in order to find area, you take length times width. Well, you're multiplying the same number times itself, which we can rewrite with exponents, so it would be 2 squared. So the area of this would be 4, okay? So if you know the area of a square, you can work backward to find the length of a side. So if your square has an area of 4 square units, to find the length of a side, all you have to do is just figure out the square root of 4, okay? And this is the symbol that we use to denote square root. And we say it, square root. So if you see this, you would say the square root of 4. And it's different from the number 4, okay? So the square root of 4 is the same thing as 2. These two things are not the same, okay? So you can't say, if I ask you, what's the side length, you can't say, well, it's 4. No, it's the square root of 4. So you have to distinguish between whether it's a square root or whether it's just the regular number. Okay, we're just going to look at these two really quick. So again, if you think about the side length is the square root of the area, okay? So if you have a square whose area is 1, whose area is 9, whose area is 16, and whose area is 25, you just have to find the side lengths. So what would be the side length of this one? The side length of this one, the side length of this one, the side length of this one. And then find the values of what is the square root of 1, what is the square root of 9, what is the square root of 16, and what is the square root of 25. And they're just trying to get you to see that they're the same thing. Okay, so just take a couple of seconds, pause for a minute, see if you can figure out what the side lengths are here. and then figure out what the square roots of each of these are here. All right, so for this one, the side is equal to 1, side is equal to 3, side is equal to 4, and side is equal to 5. And again, over here, square root of 1 is equal to 1, square root of 9 is equal to 3, square root of 16 is equal to 4, and square root of 25 is equal to 5. All right, now if you're going backwards the other way, okay, so they're giving you the side length, you need to find the area. What you're going to do is you're going to take this number and you're going to square it. You're going to multiply it times itself, okay? So you would take 12 squared, you would get this number under here. So just like how we have these up here, the square root of 1 is 1. The square root of 3 is 3, the square root of 9 is 3. The square root of 16 is 4, and the square root of 25 is 5. Well, in order to get the number under here, you have to square each of these numbers. So 5 squared gives you 25. 4 squared is equal to 16. 3 squared is equal to 9. 1 squared is equal to 1. So in order to find out what number goes under here, all you're doing is the same thing. 12 squared is going to give you this number here. 2.5 squared is going to give you this here. So you can think about this is the side length, and this number is the area. This is the side length, this is the area. So take a couple of seconds and figure these two out, B1 and B2. Pause it. All right, so for the first one, you should have gotten 144, the square root of 144. And for the second one here, you should have gotten 6.25. And then the same thing here. If your side length is 12 units, your area is going to be 144. And if your side length is 2.5 units, your area is going to be 6.25 units squared. And we're going to skip over these. Okay, on this one of the things that you need to be able to do is to take a line segment, like this one. So a line segment is basically just the length between two dots. And what we need to be able to do with that is we need to be able to find the length of this without using a ruler, okay, just by using the area of a square. So remember, we know that the side length is equal to the square root of the area of a square. So in order to find the area of the square, the first thing that we need to do is we need to draw our square. Okay? So if you remember in one of the very first lessons that we talked about, drawing the square, if you can figure out what the slope is from one point to the next, so you go up 1 and over 2, just like our driving directions. So you do your x and your y. Okay? So from your x, you're going to go over 1, 2, and your y is going to be up 1. So maybe I should have drawn this a little bit differently. I'm going to do okay. So now to get your new driving directions, you're going to flip-flop. Okay? So you're going to do y and you're going to do x, but you're going to keep the numbers. Whoops. 1, 2, 1. Okay? Now, in order to make this work, we need to go down this way. So our y, instead of going up this time, is going to go down. Okay, so we're going to go from this point, we're going to go down 2, and our x needs to go this way 1. And again, same thing here. Down 2 and over 1. So we're always doing the same thing. We're doing it once from this end point and once from this end point. But we're following the same driving instructions both times. Down 2 and right 1. Down 2, right 1, down 2, right 1. So now we have the square right here. Okay? Now in order to find the area, what we need to do is, what we're going to do is we're going to draw a box. We're going to draw a square around our square. And that square that we draw needs to touch all 4 vertices. Okay? So what we're going to do is we can't say that this is 2 right here because this distance here is longer than this distance here. And we know that straight across between 2 dots would be a distance of 1. So this distance here is slightly longer. So we're going to draw a box. We're going to draw a box around our square, okay? And we're going to find the area of that. Of the big box, okay? So remember, we're counting the spaces between the dots. We're not counting the dots themselves. So 1, 2, 3. So this is 3 up here, and 1, 2, 3. This is 3 over here. So the big red square has an area of 9. Now, in order to find the blue square, what we need to do is we need to subtract out these little triangles that are on the sides here. And we know that if this triangle, whatever area this triangle has, this area is going to be the same, this is going to be the same, this is going to be the same. So we know that the area of a triangle is base times height divided by 2. So our base is this distance here, it's 1, and the height is this distance here, which is 2. So 1 times 2 is 2, and then take that and cut it in half. So half of 2 is 1. Which means that each one of these corner pieces right here, we'll outline those in green, each one of those triangles is in an area of 1. So all 4 of these triangles together give us an area of 4 that we're going to subtract away from that big red square that we had on the outside. And when we do that, what we get is the area of this box inside here. Okay? So we found the area of the big box, and we subtracted out the areas and the corners to get the area of this box right here. And then, once we do that, we find the side length. So the side length is equal to the square root of the area. So if we know that the area is 5, we know that the side length, this original length that we started with here, is the square root of 5. Okay? So basically what I'm going to have you do, I'm going to attach some PDF files, and I'm just going to have you practice drawing the squares and practice finding the area and then finding the side length. Okay? So practice finding your area, practice drawing your square. It's going to give you a bunch of side lengths. So practice drawing your square. Once you get the square, do your big box on the outside, subtract out your triangles to find your area. Your side length is gonna be the square root of your area. I think we talked about the properties of squares, but what makes a square? That's a good review. So remember, squares have 4 equal sides. And squares also have 4 90-degree angles. Okay, so when you draw this, make sure that what you have is indeed a square and not a parallelogram or a rectangle. Okay, if you have questions, let me know. I will try to get everything attached and sent to you so that you have it and post it on the website also.